Namaste. I, JV'n Dr. Parveen Parihar, working as assistant professor at Jyoti Vidyapit Women's University in Department of Pharmaceutical Science. So today we are going to record the lecture of the organic chemistry second of third semester from the course of B Pharm. So the second unit of the chemistry second is the phenol. So we study about the phenol. Just let's start with the general introduction of phenol. So we are going to study in this video is that the nomenclature, how we do the nomenclature of phenol, the acidity, its the effect of a substituent on the acidity of phenol. Okay, it's not working. Okay, synthesis of phenol, how phenol is synthesized, how phenol is going to synthesize its reaction in the reaction of phenolic hydrogen. That means this hydrogen, its esterification, how we do the esterification of phenol, Friedel-Crafts acylation reaction that is given by phenols, Williamson and synthesis, the reaction of phenolic benzene rings. So all this content we are going to cover in this lecture. So let's start with the nomenclature of phenol. So in phenol functional group, we add the suffix we add commonly is the phenol, and if we add the phenol as a prefix, then we use hydroxy. So the numbering of the ring begins at the hydroxy substituted carbon and proceeded in the direction of the next substituted carbon that possesses the lower number of carbons. So in this way we start the nomenclature of phenols. So what is mean by ortho, para or meta in phenol? If it is mono substituted, there is no need to consider ortho, meta or para. Mono substituted phenol are categorized using the prefix ortho, meta and para depending on the placement of the substituent. In phenol, that the other substituent is placed on which position we consider the name as its mono, para or meta substituted phenol. The priority is given from the hydroxyl group or the hydroxy, which is the higher priority functional group in phenols. For example, we can see here the metacresol, in which the methyl group is on the meta position of the hydroxyl group. The another example is the 5-chloro-3-methylphenol, in which the methyl group and the chlorine group both are present on the meta position of the phenol. And in resorcinol, both the OH group are present on the meta position of each other. In para-hydroxybenzoic acid, where the OH group is present as not as the priority group, here the priority is given to the carboxyl group, so the hydroxy group is present as the prefix, or we can say that it is present as a substituent, so we consider it as a substituent and the name will be para-hydroxybenzoic acid. The another example is the 2-hydroxy-4-methyl acetophenone, in which the priority is given to the phenol acetone group. Priority is given to this group. So here also the hydroxy group is present as the substituent and it is on the ortho position of the group. So this is how we do the basic nomenclature of phenol. Now let's talk about the acidity of phenol. That what is obviously the nature of phenol is acidic. It is acidic in nature because of the because it can release the H plus ion when it give reaction. So its nature is acidic. So phenols are more acidic than alcohol. If we compare the phenol with alcohols, then we can say that phenols are more acidic as compared to alcohols. Why? Because in phenols the carbon anion which is formed due to the release of H plus ion, it is more stable than in alcohol because of the resonance of the phenolic ion. So but less acidic than the carboxylic group. But if we compare phenol with carboxylic acid, it is less acidic as compared to carboxylic group. So the comparison is done with alcohols and the carboxylic acid. So it is more, phenols are more acidic than alcohols but less acidic than the carboxylic acids. So the negative charge of the phenolate ion is stabilized by the resonance due to the electron delocalized onto the ring as shown in this slide. So we can see in this slide also that the negative charge, we can see that the negative charge which is generated because of the release of H plus ion, it is delocalized onto the ring and shows the resonance with the benzene. So due to this resonance in the phenolic ion, this is more stabilized as compared to the alcohol. So it is more acidic than the alcohol. So if we talk about the effect of substituent effect on acidity, if we attach any other substituent in phenol, then how it is going to be change the acidity of the phenol. Let's see. Substituents, particularly those located at ortho or para, the OH group, can dramatically influence the acidity of the phenol due to the resonance or inductive effect. So it is particular about the position of the substituent, that where is the substituent present in the ring of the phenol. So if the substituent is present on the ortho position or on the para position, ortho position or on the para position, on both the position they affect more onto the acidity as compared to on the meta position. So if the substituents are present on both these position, that is ortho and para, then it will dramatically affect the acidity of phenol. And the reason for this acidity influence is because of the resonance, or we can say that because of the inductive effect. So electron withdrawing group enhance the acidity, electron donating substituent decrease the acidity. So we can say that we have discussed that on if the substituent is present on the ortho and para position, they affect most the acidity of phenol. But if we talk about the substituent, that which type of substituent increase the acidity or which types of substituent decrease the acidity, then the substituent which are electron withdrawing in nature, they will increase the acidity of phenol, and the group which are electron donating in nature, they will decrease the acidity of phenol. So here some of the compounds are shown and their pK value for the acidity comparison is shown, that how the substituent affect the acidity of phenol. Now it comes the synthesis of phenol, that how we can synthesize the phenol in laboratory or at industrial level. First is the alkali fusion of sulfonate, that when phenols can be prepared in large amount or in large quantity by the pyrolysis of the sodium salt of benzene sulfonic acid. If we react sulfonic acid in presence of salt, then it will give the sodium salt of sulfonic acid, and further if we react this sulfonic salt with NOH in presence of NOH, then it will give us the phenoxide ion, and further in the presence of water, finally it will convert into phenol. This is a reaction from the sulfonic acid. So the another reaction is the Dow process. This process is called as a Dow process. In this process, the chlorobenzene is used. It reacted with the dilute sodium hydroxide. At the temperature is controlled at 300 degrees centigrade to 3000 degree, and the pressure is also controlled at the 3000 psi. Under this controlled environment, that is under controlled pressure and under controlled temperature, the chlorobenzene will give the phenol. The third synthesis reaction is the air oxidation of cumene. The air oxidation of cumene, that is isopropyl benzene, leads to the production of both phenol and acetone. This is called the phenol. The IUPAC name of cumene is the isopropyl benzene. The common name of isopropyl benzene is the cumene. If we react cumene in presence of air at 130 degree centigrade, then it will give the cumene hydroperoxide, which further will on hydrolysis will convert into phenol and acetone. Both the two products can be prepared with cumene. So these are general three reactions by which we can prepare the phenol. So that's all for today's lecture. Further we will discuss into next lecture. Thank you.